All right, hey guys, this video is on factoring completely. And when you have to factor polynomials kind of like this, you gotta have to take some multiple approaches. So you might have to pull out common factors because oftentimes polynomials will just see one glaring common factor of all of the terms. And then after that, you gotta be with my main man over here and use that rectangle. See if we can actually figure out if the remaining polynomial that's in parentheses, the part that we got factored out of, if we can make a rectangle out of that and find more factors, right? The base times by height and write our answers in fully factored form. So still got a lot of people working on this one. It's pretty early in the day. I figured I'd get this video out to you and maybe talk about B. Just get this one down as an example. How would I factor that one completely? And I have a list of 3 steps to follow. Now, normally I have these 3 steps listed out in the classroom. I just have them out all the time on the wall so people can look at them real quick, remind themselves, because it takes some practice remembering these 3 steps. Step number 1 is what I recommend. Pull out your common factors from this particular polynomial expression. Then after that, step number 2, we would look to see if, well, once I pull out my common factors that I can see, right, visually here, this term here, this term here, this term here, that's got some common factors here. After we pull those out, what remains, after I pulled out those things, what remains, can I use a generic rectangle? Can I set up a generic rectangle and can I actually fit all my x squareds and all my x's? And notice here, this is x cubed. Ooh, interesting. X squareds and my numbers. And then do I know where my x is going? Can I actually make a rectangle of this and factor even a little bit more? Final step, step 3. This is the easy part, but a lot of people forget it. You got to remember your factors from steps 1 and steps 2 to write your final answer of what the heck this is. Because again, you're trying to represent what this represents as a product, right? A series of factors together one another here, okay? So we'll go through each one of these together, and I just wanted to point this out here too as well. I've already attached this to Google Classroom. I have this down as notes with a different polynomial here. Notes, factoring completely. So if you listened to me a second ago, I said I have this up on the wall in class in a normal year because we're gonna have to factor a lot when we do quadratic functions. This isn't going away, guys. We're gonna keep factoring. It's not gonna go away for the rest of math here, I guess. Factoring is pretty important. But I have it up on the wall to help you guys out a little bit here. So this one you should have done in class on step, let's see here, on number 7, for instance, 10x squared plus 25x minus 15. You already have the answer, but you might be questioning to yourself, what's the most structured way I can do this? How can I get organized to get that as an answer? And my recommendation is to follow these steps here. Pull out common factors. So look at this one here. Common factors of this one, well, common factors include variables, or they include constants, right? Constants are just like kind of the numbers you're used to saying, like the number -3 is a constant. But anyways, x squared, x term here, and then here we don't have an x. So we can't pull out an x. There's no variable to pull out here. But if we look at our constants, right? This is a coefficient constant. That's a coefficient of this. And this is just a constant here. A common number that goes into 10, 25, and 15, well, they all end in 5 or 0. So that means 5 goes into both of them, okay? 5 times 2 gives you 10. 5 times 5 is 25. 5 times -3 is the 15 there. So pull out that 5, okay? We get 10x squared. Well, how can I write that as a composite? How can I write 10 as a composite number? Well, that's just 5 times 2. How can I write 25, which is a composite number in terms of its factors, right? 5 times 5, good to go. What about 15, right? 15 is 5 times 3, right? So I could leave the 3 here and it's negative, right? So we got to do that. Okay, there's first step. Second step is taking this trinomial, okay, and popping it into a generic rectangle, okay? So I pulled out the 5 already. I have what remains here is factorable on the inside, right? So we got to factor the inside of this here. So this is a trinomial here, and what we've been doing is factoring trinomials a lot in the past week or so. That means see if that trinomial, if you can make a rectangle out of it. You can make a rectangle out of that, boom, we found some more factors here, okay? So here I put 2x squared here. I put -3 here, right? Remember, your diagonal is going to multiply to be whatever this multiplies to. Here's where your x's go along the other diagonal. I got 5 x's, got to fit them somewhere. Ooh, they got to multiply to -6x squared, and they're going to add to 5x, right? Remember, 5x goes here, and then this diagonal's got to multiply to -6x squared. So the question is, what does this diagonal multiply to? Well, it multiplies to -6x squared, but it's got to add to 5x too. So that's the solution to that one here. It's a negative that it multiplies to. So one of these is negative, one's a positive. Got to sum to 5. Hopefully you'll be able to figure that out. Get your factors, right? Get your factors and write your final answer in completely factored form. So step 3, again, is the easy step here. And a lot of people forget it. You got to write this whole original sum, right? You got to write it in fully factored form. So don't forget, you had factored out a 5 in step 1. And then in step 2, that's where you factor inside parentheses. parentheses. So we found two factors, x plus 3 times 2x minus 1. That equals 2x squared plus 5x minus 3, but it doesn't equal this, right? Because this times 5 equals that. So remember, what you do in the very last step, I might circle it real quick here and then get rid of it for the notes here. You got to take this factor, and this factor. That's what's going to equal these three things. Check, check, and check. We grab this one, put it there, grab that one, put it there, and grab the 5, put it there. Let's get this as a video for your example. Last but certainly not least, we have this one. Let's factor this one together. Shall we? Shall we do it? Okay, step number 1, pull out common factors. Well, I see a 3 here. I see a 6 here. I see a 45. So 3 is a prime number, so maybe you should ask here. The only thing I can pull out of this is this prime number 3 is 3, right? There's no reason to pull out 1, for instance. So 3, does it go into 6? Yeah, it goes into 6 twice. Does it go into -6? Goes into -6, -2 times. Does it go into 45? Sure as heck does. 3 times 15 brings you to 45. Okay, so you can do 45 divided by 3, do it in a calculator real quick to make sure that 3 does go into it, but you gotta move quickly through that. Okay, so 45 divided by 3 is 15, so we're gonna have 15 here, whatever. So I'm gonna pull out a 3, and then the question is, can I actually pull out anything else? You should go through this whole thing here because pull out common factors could, remember, a factor could be a constant or it could be a what? It could be a variable. Okay, it could be a variable. I got to pull out variables or constants. And this one here, I'm going to pull out the constant array, right? 3 goes into 3 once, goes into -6, -2 times, goes into -45, -15 times. So maybe I'll put the 1 down here. Maybe I'll put the -2 right here. And maybe I'll put the -15 right here. Question, do we have a variable that goes into each of these terms? Here's the first term, here's the second term, here's the third term, right? Terms are separated by pluses and minuses. Yeah, sure as heck we do. Look, we see an x in all of these here, so we can pull that x out. This is x to the first. We can pull that 1 out. If we pull one of these out here and we pull one of these out there, okay, we move the x out to the outside, right? So that's what we can do. We can pull out one of the x's out of all 3 of those terms, pull it out. Now this is x cubed. That's going to become x squared, okay? X squared, let me get rid of this -1 here too. So x squared minus 2, I pulled out an x, so it would be 2x, okay? Minus 45x, I pulled out that x. Well, 3x times by -15, that's -45x. I'm good to go, okay? I might clean this up a little bit here so that we can see this, like, it looks a little bit more like the trinomials we're used to seeing, and then we'll proceed to the next step here. So, all right, so I had 3x times by the quantity, x squared minus 2x minus 15. And I'll get this out of the way as well. Okay, so this is one of the factored forms of that. Is it completely factored though? Or can we factor it again? Can we get this even more factored? Can we find more factors here that we can separate out on this? And it turns out we can't, okay? The next step of this is to analyze this portion. 3x, can't factor that factor. This factor, we can't even factor the factor of this, right? X squared minus 2x minus 15 is a factor of this because we've multiplied it by 3x, it would become this. But that in of itself, this thing right here, there are some composite polynomials that when multiplied together would become x squared minus 2x minus 15. And how do we figure out what those smaller polynomials are? We can try to factor x squared minus 2x minus 15. And the way we do that is generic rectangle. Okay, step 1, pull out common factors. Let's remind ourselves what we did there, right? We did these 3 terms. 3x went into all those. Okay, now this next thing here we'll handle in green. We're going to put this information into a generic rectangle. Okay, I got to do my minus 15 here. Diamonds. Okay, and now I got to figure out where my x's go. Okay, so I'm looking for numbers that multiply to -15 and add to -2. Well, if they're multiplying to a negative number, I'm going to know that one of these is negative and one of these is going to be positive. 15 doesn't have very many factors. You got 15 and 1. That doesn't help us to get to 2. 2 is too close to 0, so 15 and 1. What about 5 and 3? Does that relate to 2? Yeah, 5 minus 3 would be 2. I guess 3, positive 3 minus 5 would be -2. That's how you get there, okay? So that's how you get there. We got that one here. Then you don't have to fill out this portion here because this one's an easier one to factor, but I might as well finish out the diamond. Okay, so there we go. We have -2x's, which is what is part of the polynomial here that we're factoring, and then we have x squared minus 15, which is the remaining parts. So now we have this trinomial in a rectangle. We have 3 x's of those, though, so we're not going to neglect that. That'll be in our final answer. We'll get to that later. So now we can factor this generic rectangle here. We know that this is x squared, so there's only one option here. X times x gives us x squared. And then this is going to be minus 5 because, x times negative 5 is negative 5x. And then finally, this is going to be positive 3 because 3 times negative 5 is negative 15. 3 times x, 3x. Cool. Everything checks out here. Okay, so now I've found some factors, right? Found some factors. So this thing here equals this times by this, right? They equal each other, right? This is the outside of a rectangle. That's one way we could write this polynomial's area as width, base times height, or we can write it as the sum of all its parts, right? This is the sum, this is the product. They're equivalent to one another. They're equivalent to one another. So last step here, remember, our whole goal of this was to write 3x cubed minus 6x squared minus 45x in completely factored form as much as we can factor it. So last step here, right? Final answer. Remember to include all the factors you found. Well, we knew that 3x went into 3x cubed minus 6x squared minus 45x because we just saw it visually. So we can write that as a factor. Can't factor that out at all. This thing here we could factor, and we factored it to x minus 5 times by x plus 3. Okay, plus x plus 3. So these are the 3 parts right here, and right here. We need to put right here, and right here. And therefore, my friends, we have finally solved this. This is the completely factored form. We'll call it the completely factored form. It technically is the prime factorization of that polynomial. Algebra is pretty cool, isn't it? It's pretty neat. All right, email me if you have any questions. Excellent work today, guys. Have a great rest of your Monday. Hey, it's still second block right now. Not bad. Finish it up for homework and little asynchronous problem set tomorrow. Take care. Bye.